Good morning, everybody, and welcome back. I hope that you all have enjoyed your nice 4-day weekend with the snow. We're able to enjoy it a little bit. So we are going to continue working with adding and subtracting rational expressions, with adding those algebra fractions, except today we're going to get into a little bit more complex examples of these. And so just a couple of reminders here, a couple things to remind you. For us to add fractions together, what we've got to have is they have to have the same denominator to be combined. So if we're in a situation where they don't have the same denominator, what we can do is we can find the least common multiple. We can multiply each one to get it to that, and then we can then combine those two. So we're going to look at some different types of examples of these and kind of give you all some intuition for how to do this. So the first example we're going to look at, we're subtracting 7 over x minus 5x plus 7 over x minus 9. Now, for us to get in a spot where we are allowed to combine these things, what we've got to do is say, okay, well, the least common multiple here, both of these are individual factors here. If you want to put parentheses around that to make you think of that as one quantity, this is just the quantity of x minus 9. So these can't be factored at all. So like I'm going to have to include both of these things right here. So I'm going to include the x, and that will take care of that. I'm going to include the x minus 9, and that will take care of that. The least common multiple that I can get is just, if they have nothing in common, is just those two things multiplied together. So now what we're going to have to do is say, okay, well, I'm now going to have to multiply each of these things to get it to this least common multiple of x times x minus 9. So on this side, this is missing, this 7 over x is missing an x minus 9. So I'm going to say 7 over x, and then minus 5x plus 7 over x minus 9. So over here, I'm going to multiply both of these things, the top and the bottom, to keep the fraction the same, times x minus 9, times that 7 right there. And then over here, to get to this least common multiple, I need to multiply the numerator and the denominator by an x over x. So if we distribute here, this is going to give me 7x minus 63 divided by x minus 9 times x. This numerator for the second one is going to be, so minus 5x squared minus 7x over x minus 9 times x. And so now we've got these things to the same denominator right there. And so now it's just basic subtraction. So the denominator is going to remain the same here. We're going to say the denominator is x minus 9 times x. The denominator, or the numerator here, so let's see. Nothing to subtract that 5x squared with, so that's just going to be minus 5x squared. 7x minus, and that should be a plus 7x right there. 7x minus 7x. Those are going to cancel out, and then negative 63 is right there. And so now we have combined those two rational expressions into one expression, So let's look at another example that works a little similarly to that. Works similarly to that example that we just looked at. So we're adding 3 divided by the quantity x minus 5 plus 7x divided by the quantity of x plus 8. So again, the least common multiple here, we've got neither of these are they can't factor at all. So we've just got to include each of those. So I'm going to include x minus 5 in my least common multiple, and that takes care of that factor right there. And then I'm going to include x plus 8, and that will include that factor right here. And so now we're going to say, all right, well, if I want to get to a spot where I can get these denominators the same, 3 over x minus 5 plus 7x over x plus 8, I need to multiply each of these things to get to the LCM. So this x minus 5, to become the LCM, I need to multiply the top and the bottom by x plus 8. And then this x plus 8 over here, I'm going to multiply by x minus 5. So I'm going to distribute here. So 3 times x is going to be 3x. 8 times 3 is going to be plus 24. This is over x plus 8, x minus 5. And then the other one that we've got here, so plus 7x times x, that's going to give me 7x squared minus what? That's going to be 35x. And this is going to be over x plus 8 divided by x minus 5. And so then the last thing that we'll do is we'll just go ahead and combine these. They have the same denominator now. So to x plus 8 times x minus 5, let's see, 7x squared. 3x plus a negative 35x is going to be a negative 32x. And then we've got a plus 24 right there. We've got a plus 24 right there. So with that, typically you will have to check and see if you could factor this down at all. I do not believe that this will factor. So we might get to an example where it can factor. You should get in the habit of checking to make sure that this can't simplify at all anymore, that we can't cancel out an x plus 8 with an x minus 5 at all. But I think in this case that we are safe. So the next example that we're going to look at here of adding rational expressions. So here we've got x plus 7. So we got x divided by x squared minus 49. That's one quantity right there. The other quantity that we've got is 3x plus 1 divided by x plus 7. Now, x squared minus 49. Anytime that you see an exponent of 2, you should try to see if it will factor. Because it turns out this x squared minus 49, that is our difference of squares identity, which, remember, factors to a plus b times a minus b. And so in this case, we've got x squared minus 49. That's the square root of 49 is 7. So that denominator is actually going to factor to x plus 7, x minus 7. And so now what we're going to do is we're going to say, okay, well, this is actually x plus 7, x minus 7, plus 3x plus 1 divided by x plus 7. Because remember, when we're doing the LCM, we need to make sure to factor if we can. The first two examples we looked at did not factor, but that will not always be the case. So now when we go to find this least common multiple over here, we're going to say, okay, well, one of the factors that we've got here is the x plus 7. Now, the x plus 7 takes care, since it is common, there's one in each. We only have to list it one time. It is only one multiple in each. Even though it appears twice, you only list it once because it's only common. It only appears as a factor once in each. And then the other factor that we've got here is x minus 7. So when we're looking at this now, this fraction over here actually already has our least common multiple. There is nothing required on our end to get it there. Now, over here, x plus 7, to get it to x plus 7 times x minus 7, we've got to multiply the numerator and we've got to multiply the denominator by x minus 7, excuse me. So what that looks like now, we're going to be in a situation where we'll have to simplify this by FOILing. So let's see. I'm going to write the first one, x over x plus 7 times x minus 7. And this is going to be plus, let's see, 3x times x will give me 3x squared. 3x times negative 7 will give me negative 21x. 1 times x will give me plus 1x. 1 times negative 7 will give me minus 7. And this is still over x plus 7, x minus 7. I'm a little tight on room here, but that is okay. So let's see here. So now we are combining all of the like terms across. So we're going to have the common denominator here. We're going to have the common denominator here of, let's see, of x plus 7 times x minus 7. And let's go ahead and combine our like terms. So I see a 3x squared. I don't see any other 3x squareds. So we've got 3x squared there. So x minus 21x is negative 20 plus x, that's going to be negative 19x. And then we've got minus 7 here. Minus 7. So this right here is the result of adding those two fractions together. That's the result of adding those two fractions together. And so what we're going to do is we're going to look at another example. We're going to step it up in difficulty just a pinch. Just a pinch. But that right there is how the thought process remains the same. We're going to factor, we're going to find the LCM, we're going to multiply, and then we're going to combine and simplify. Combine and simplify. So let's look at another example real quick. So here we've got x plus 1 divided by the quantity x squared minus 6x plus 16 minus x plus 1 divided by the quantity x squared plus 6x plus 8. And so now our denominators here are both things that they've both got this x squared. They're both trinomials. We need to check to see if these things are going to factor or not. So I'm going to set up the AC method for both of these things real quick to see if we can find any factors that work. So we say 16 and adds to negative 6. So numbers multiply to 16 and add to negative 6. Those would be negative 8 and positive 2. So I'm going to rewrite this first denominator with, since a is 1, as x minus 8 times x plus 2. Whenever that constant, or the coefficient rather, in front of x squared is 1, you can just, whatever those factors are, that's what your factors are going to be there. And then the other one, we've got numbers that multiply to 8 and add to 6. Those are going to be plus 4 and plus 2. So that's going to be x plus 4 times x plus 2. And then now we're ready to go and find our least common multiple, or LCM here. So for our LCM, we need to make sure to include each of these factors. So I'm looking, is there anything common? They've both got this x plus 2. So I'm going to include one x plus 2. There is one x plus 2 that is common. The next thing that we're going to look at is we're going to say, alrighty, well, there's an x plus 4 in there. So I'm going to include that as well. And then I'm also going to include this x minus 8 right there. And so now I've got my LCM. So for me to add these fractions together, what I need to do is get them to a common denominator. So I'm going to look at this first fraction and I'm going to say, what is missing to get to this LCM right here? I've got the x plus 2, got the x minus 8. I need to multiply this by the x minus 4. So I'm just going to multiply x minus 4 over x minus 4. And then over here, same thought process. You ask yourself, what are you missing? I've got the x plus 4, I've got the x plus 2. I need the x minus 8 up top and down low. We're going to have to multiply these things. We're going to have to FOIL these things out. So now what we've got here, we got a situation. We got the x times the x right there. That's going to give me x squared. X times the 1, that's going to give me 1x. Negative 4 times x is minus 4x. Negative 4 times the 1, that's going to give me a minus 4. And this is still over our same denominator here. Still over our same denominator here. And then For the other one, x times x is going to give me x squared. X times negative 8 is negative 8x. 1 times x is 1x. 1 times negative 8 is negative 8. So we've got x minus 4 times x minus 8 times x plus 2. And now we're ready to combine these things. Now we're ready to simplify these things a little bit. So let's see. X squared minus x squared. That's going to give me, those are going to cross out. We're subtracting here. So we've got 1x minus 4x. That's going to be negative 3x. Negative 8x plus 1x. That's going to be negative 7x. So we're doing negative 3x. Now here's the thing. Don't get lost with these double negatives. Negative 3x minus a negative 7x. That's negative 3x plus 7x. So that's going to be a 4x for us. And then we've got negative 4 minus negative 8. So negative 4 plus 8 is going to give me a positive 4 here. It's going to give me a positive 4 there. And our denominator is still going to remain the same. We've got x minus 4, we've got x minus 8, and we've got this x plus 2. So we are actually, we're going to call it here for the day. I want to give us some time to really soak in this adding, subtracting mindset. I did have something else on tap, but we're going to pause the brakes here. Coming off a snow day, we haven't really looked at a ton of this mathematics yet. So if you all have any questions on this, please let me know and we can look at it together. Other than that, I hope that you all have a good weekend, and I will see you all on Monday.